Let's conclude the lesson on using determinant method to solve simultaneous equations of three unknowns. So we're given the question in the previous video, and I'm sure you have tried it. Now we are just here to solve it together. So let's now begin to evaluate our determinants 0, 1, 2, and 3. Let's begin. So for the coefficient term, that's 1. Cover this side, and then we are left with this. So that means we are left with 2, 1, minus 5, 1, minus 1, 1. Okay, and 4, 2, minus 3, 4, 2, and minus 3. And the determinant here is simply minus 21. Now for delta 1 now, that means the x coefficient or the x variables are omitted, and we are left with this. So we just take out the coefficient there, and that of y, this and this, and the coefficient term. So that's 1, minus 5, and 1, 1, minus 5, and 11, minus 1, 1, and minus 6, 2, minus 3, and 8. And when we perform the determinant here, we are sure to get 21. All right, moving on, let's evaluate delta 2. Delta 2 is for the white term, so that's coefficient of y are omitted, and we have 2, this and this. So with that being said, so with the 2, all right, minus 5 and 11, 1, 1, minus 6, 1, 1, and minus 6, 4, minus 3, and 8, 4, minus 3, and 8. And when we perform the determinant of this operation, we are getting 63. And finally, for the z or z, we omit these terms, and we are left with this 1, and finally this. So let's do that together now, and we will know that we are omitting z. So it will be 2, 1, and 11, and we go in that order: 2, 1, and 11, 1, 1. Okay, we are omitting z, so this is 1, minus 1, and minus 6, and finally 4, okay, 2, and 8. And when we perform the determinant for this operation, we have 42. Now, having done all this, let us now evaluate our z, x, y, and z. So we know that our x divided by delta 1 is equals to minus 1 divided by delta 0, because we understand from place signs that it is positive, negative, positive, and negative. So my x now is divided by the delta 1, which is 21, and is equals to minus 1 divided by this, which is what? Minus 21. And simplifying this, we have x to be equal to 1. Moving on to y, that's minus y divided by delta 2 is equals to minus 1 divided by delta 0. Okay, so I make our substitutions. That's my y divided by delta 2, which is 63, is equals to minus 1 divided by delta 0, which is minus 21. So simplifying this further, we have y to be equal to minus 3. And finally for z is equals to minus 1 divided by this. So I have my z to be delta 3 to be 42, and my delta 0 or delta naught is minus 1 divided by minus 21. and therefore we can have z to be equals to 2. So we can come to a conclusion that for the expression or for the set of simultaneous equations given, that x is equals to 1, y is equals to -3, and z is equals to 2.